You may have noticed in the previous video, we were approaching that limit from the right-hand side, and there was a little notation. That's what we're going to be looking at next. So at vertical asymptotes, the function values are not approaching a number. Instead, they are reaching towards either negative infinity and or positive infinity. Now recall the limit as x approaches a is defined if x is approaching a single value from both the left and right of a. However, we can describe limits as left-hand and right-hand limits. For a left-hand limit, we use the notation x approaching a with a negative sign up where an exponent would be. And for a right-hand limit, we would use x is approaching a with a plus sign. For the limit as x approaches a to exist, the limit as x approaches a from the left of a function must equal the limit as x approaches a from the right of that function. In other words, we must have the same limit from both sides. So let's take a look at example B. In number 1, we're asking for the limit as x approaches 2 from the left. Looking at the graph to the right, as x is approaching 2 from the left-hand side, the graph is getting closer and closer to the y value of 3. In number 2, they're asking us to find the limit as x approaches 2 from the right. So looking at our graph, as we approach x from the right, the function is approaching a y value of 1. So in part 3, they're asking us just for the limit as x approaches 2. So remember that in order for that to exist, it has to approach the same y value from the left as it does from the right. So we would say that this limit, DNE, or does not exist. Now let's take a look at number 4, where they're asking for the limit as x approaches 5 from the left. If we're looking at the number 5 here, from the left-hand side, it looks like the y value is close to 2, even though the point itself is lower. Now on number 5, it's asking us the limit as x approaches 5 from the right, which again is approaching 2. Since the limit from the left and from the right are the same, that means that the limit as x approaches 5 is also 2. Now in example C, they're asking us to estimate the limit as x approaches 2 of the function x squared minus 2x, all divided by the quantity x squared minus 4, by filling in the following table to 6 decimal places. What this table does is it gives us values less than 2, let's say 1.9, then 1.99, 1.999. Even though it's undefined at 2, if we were to put each of those values in for x into our calculator, for the first value of 1.9, we would get 0.487. Plugging in 1.99, we would get 0.4987, and then 0.49987. If you try to plug in 2, you're going to get an error. So notice the closer we get to 2, those values are getting closer and closer and closer to 0.5. On the right-hand side, we're going to plug in values getting closer and closer to 2 from the right. So again, thinking of it like a number line, if this is 2, we would have, 1.9, 1.99, or from the right, 2.1, 2.01, 2.001. You're getting closer and closer to 2 for an x. So plugging in 2.1, we would get 0.5122. Next, it would be 0.50125, and then 0.50012. And for the number 2, we'd get an error, which means the limit is getting closer and closer to 0.5 because it's approaching the same number from both directions.